All right, to get the recording going. Good. Excuse me, folks. Hey, everybody. Thanks for joining us today. Uh, Wanted to apologize first off for not being able to be with you guys last week. Had a meeting come up at work. Let me grab a drink here a second. I had a meeting come up at work that I couldn't get out of, so I had to deal with that. Sometimes happens, but hopefully not too often with that. As I recall from the last time we met 2 weeks ago, we kind of were looking to maybe get a little bit more a sense of hands-on kind of demoing some of the stuff that we talked about around containers and Kubernetes and such, rather than just going through the slide. Where does that sound right, Crystal and folks? Okay, great. All right, awesome. Well, I'll tell you what, I'll run through a couple of demo things today, and we'll do this maybe just a little bit more free form for you guys, and you can jump in chat or on the audio with questions or things that you would like to see and stuff, and I'll kind of try to keep an eye on that and just address any topics that come up there. But I'll start rambling on again. You guys can jump in. I'll share my screen here. Let me do this. Let's see, VirtualBox. So what I'm sharing here is just a little virtual machine where I have Docker and Kubernetes and things set up, and I thought I would just show you. This is actually from one of the classes that I teach on O'Reilly's platform. And let me just get to my notes here. What I'll show you is we'll go through and take a look at putting a container together, the Docker file, the images, the pieces that go into it, the layers. We'll put it into a registry, and we'll see what it looks like in Kubernetes. And hopefully that will kind of help relate the various things that we've talked about before back along that. So what I've got here, can you guys see my screen okay? Should be a couple of terminal windows here. So what I've got here, this is a class area that I work in, and it's a Docker area. And I've got a couple of whoops, not in that window. Let's go to here. So I've got a couple of things in here. The first couple of things we'll look at are the Docker file ones. So you may remember that we talked about the idea of a container being kind of like a virtual computer inside of another computer. In other words, it is a way to partition off operating system resources like namespaces and memory and different pieces, and giving that dedicated portion of system resources to an application. And Docker kind of wraps around that to make the application running inside feel like it's running in its own independent virtual machine there, its own machine, its own system. And when we put that's what a container is. What goes into making a container is actually what we call an image. The image is like an image where you might install software on a machine and you provision it. In other words, you put down the layers. If you think about setting up a new computer, if you've ever done that, you install the operating system, that's like one layer. You install an application, maybe it's like a Microsoft Office, you install another one like maybe it's antivirus, those kinds of things at different layers. And those layers get stacked together. And that becomes the set of software that makes up the image, the provision things that are configured, installed, if you will, into that image. And then you can start running that image to make the container. And a container just adds that extra read-write layer on top of it. So when we talk about creating an image, we usually start with this idea of a Docker file. Now I've got two in here, so they're very specifically named, but most commonly it would just be called a Docker file. So if I take a look at, let's take a look at the database one here. These are Docker files that I use to build the two parts of an application I use in the class. One part is for a database, MySQL database for data, and another part is for a web application. So I'll walk through a little bit what's in each of these, just show you. So this is a pretty simple Docker file. Basically what it says is start with this MySQL 5.5.45 image. What this means is to start with a image that somebody else has created. So if I were to go out on, let's see, it should be, I think, hub.docker.com. Yep. Let's see if we can find it here. I don't think I have to log in. So I'll search out here. Hub.docker.com is a place where people put in different images. They create these images that you could start with or other images they want to share with other people. For example, here's the MySQL one. And Docker Hub, it's like a repository, much like a source code repository would be for source code. This is a repository for Docker images or images that we could use to build containers. And here's the one for MySQL we're looking at. And you can see there's been 10 million plus downloads here, bunches of stars. Stars are how people say if they like it or not, is the official image. And if you go into it, let's click on this. This is MySQL, and it tells you if you want to get the latest image, all you have to do is this Docker pull command. So on our side, we can just download a Docker pull to get the MySQL image down to start working with, or we can specify it as the base image in our Docker file. So we have the supported tags here. You can see all the different versions that people have put in over time. And most of these will be, if you remember, we talked about this idea of a semantic version, a three-part version number, this sort of major, minor, and what they call the patch in there. But you can pick these versions. These versions will usually be tags, like you can see here, from MySQL 5.5.45. So without any other kind of qualifier here, this basically says in our Docker file, we want to start, the first piece we want to get is that MySQL image from Docker Hub and the one that has the tag of 5.5.45, which is probably not shown in here, but it's listed, it's one we can get. And if you go out and look like on Docker Hub, you'll see the different pieces. It'll tell you about different things. It'll also tell you how you can work with these images. So if I needed a MySQL instance locally just to work with, I wasn't trying to build it into part of my images, I could just do a Docker run. Docker run is the command that takes an image and turns it into a container, turns it into something we can make changes in and use and work with there. So it gives you the instructions. Other things here to talk to you a little bit about how Docker works here, Docker run. Name, you can give it just a name to run as in there for the image or the container to spin up. There's a -e, that's simply an environment variable. So lots of the images that are out there on the Docker Hub or on any kind of repository, Docker, any kind of images, will need to be configured or pass some kind of information to say how you want to work with them or what you want them to do, kind of to customize them for your use. The most common way to do that is by passing in environment variables. In other words, the image itself, when it's running, will expect to see some value passed in an environment variable. So that's what this does on the command line. It says, look at this image, pass in this environment variable to set the password, and then go ahead and run the image that way. So you can get lots of information out here. Um, Here's examples of how to put this together with other images and such. But you can get lots of information about how to use a particular image in there, all the different kinds of environment variables you can pass. If you want to start up the image pointing to a particular database, you set up database, you can pass in a MySQL database, user password, all these kinds of things. So there's lots of information out there if you go out and are interested in digging more into that. Here's, if you look on the tags page, here's the tags page with the different tags that are available to you, common ones. You can go into those. Let's go into one of these, take a look at it. And you'll see that it lists the image layers that went in there. Now, the image layers, we talked about images being made up of these layers again. So these are the layers that went into this image. In other words, these are instructions that somebody had in a Docker file that said we're going to start out with adding some files, uh, doing some commands to add in a group in there, doing some commands to update some things, and so on. So these are all the instructions that went into actually producing this image. Again, think of it like that idea of installing software on a disk of a laptop or a desktop or something. You might have a checklist that you're going through and says, okay, now copy in these files or configure this. Same kind of idea. So this is all stuff that went into this image here. So we have that image out there now that somebody's made available to us. So the first thing that our Docker file here is going to do is to grab that image and bring it down so we have all that functionality available to us to start with. We don't have to implement the database. We don't have to put the database image together. We just have that one to start with. Then the next instruction in our Docker file is copying an entry point initdb script in there. What we're doing here is we're copying something from our local disk that is set up the way we want it into our image so it will be available to the container. So we're starting out with I have a directory out here. Let's see, right there. Let me show you what's in here. So what I've got in this directory is simply some tables, some SQL tables, and the tables are just commands that actually, or the files are just commands that do things like issue commands when the image starts running. When you start running a container, these will get executed. We're copying them into the image, so they'll be there. And well, if I can make sure I actually get into the directory here, but yeah, so all this one does is create a database. The others create tables, they'll insert data and such. So what I'm doing is I am putting I know that this MySQL database, because I've worked with it, this image says if you put stuff in this directory in the image, then when this script starts running, it will actually go and read those tables and do the instructions. So we're just kind of setting it up so when it starts running, it's going to go through and execute these and execute those instructions. That's just the way this particular MySQL image works. Um, the entry point script in there, let's see if I've got it here. No, I don't. But basically, that's just saying when we're going to start out with the basic MySQL image, the generic one we got from Docker Hub. We're going to copy in some things so that when it starts up, it'll execute those. It'll create the database we want. It'll fill in values and such. And then we're going to do entry point. Entry point and command are the things that we run when the container starts. So this entry point sh script is going to go out there and do things like say, go and get these files, execute them, and start up. So it's just a way to do it. So now if I go and do, let me copy the command so I don't mistype it. Let's do a Docker build. Sorry, bear with me one moment. Well, here, I'll just type it from there. All right, so I'm going to do a Docker build -f Docker file roar db image dot. Now let's talk about, and I'll go ahead and put the -t on here, roar db. Let's make it version v1. All right, so let's talk about what went into that command line so you understand what's going on there. Docker is, of course, the Docker application that we're using to build our image from the Docker file. Then the -f simply says, where do I get the set of instructions? By default, Docker is going to look for a file just called Docker file without any other thing. But because I have multiple in here, I had to give them different names, or I give them different names. So I'm just telling it, go out, look for the set of instructions for what you're supposed to do to create this image, in this particular Docker file. Now, when I say the dash T, that that simply means name my image. So the image I create from this, I want to call it RoarDB v1. If you're wondering what Roar is, it's just the name of the application that I'm using, the sample application, nothing special about that. But I'm building an image for the database part of my application. The dot simply means where do I find the files. They call it the context, but it says I get the files from the current directory. So what happens when I do that? It starts running through the instructions that we had up here in our Docker file. First thing it does is it grabs down the MySQL image that we ask it to. You see here it's the instruction. And this character here is just the checksum or the hash, they call it the digest, of the MySQL image that we brought down. It's just a unique identifier from that. Then I copy in stuff from my local directory into the place I want it to be in the image. That creates another layer here. Then I call it the entry point, another layer, and then essentially it kind of compresses everything into the single image so that when what you end up in the end there is we end up with this RoarDB image. Okay, so this is an image that got created from our Docker file. Now, this image is, you can see it created about a minute ago. It has a unique identifier. Here's the V1 tag. And then we've got, and it's about 213 meg. I should probably stop there. Any questions so far? And I probably need to make sure I'm monitoring the chat. For some reason I don't have that showing. Make sure I get that up. There it is. Okay. Can we edit, select the image layer, like choose what we want instead of everything? Trying to make sure I understand and answer the right question. Can we edit or select the image layer? Jasper, do you mean like can you pick different images?
I mean, like you said that when you like, for example, like when you install a software, you can choose or click on whatever you want to install. Like just besides the main software, but like there are a lot of support. I don't know, like support uh, software for. Sometimes when we install one, it'll ask you for do you want to install this as well? But it's
No,
very
it's not interactive in that sense. You basically have an image that you've defined, or if you're using a pre-constructed image like the MySQL one, you only have a certain selection to choose from that people will put out there.
gotcha. So it's like
So
all default, and you will need everything to get the image to run properly.
you would, well, depending, I mean, you could run like the MySQL image by itself,
Mhm.
because it has at the core. Let me see if I've got this here. Basically these are built on a system that built on an operating system image in there. Um, for example, if I go in, and if I don't answer your question, let me know. But basically, so these kind of images are already built with an operating system into them when they're put together. So they already have the operating system. So you could run the image as it is without adding anything else to it.
Gotcha.
Um, Let me show you guys kind of what goes into these images. Okay, so now we have the image. So the image itself, if I look at let's see if I do Docker history, remember the syntax here. Yeah, no related. It defaulted to latest. You can see all of the different pieces that went into this particular image, the original MySQL image, up to about 5 years ago here, all the different things that they ran to actually get things set up. Now, if I were to actually go and create a container out of this, so if I did Docker run, let's see, Docker run, make sure I get my syntax here right. Oops, sorry about that. Let me turn off the noisemaker. Docker run. Let's see, Docker run roar. Yeah, see, it's going to yell at me because I don't have it, the database and such initialized. Let's see. Well, I'll show you in a moment when we get to actually get it to this. Let me go ahead and do a couple of other things here. Let's look at another one of these Docker files.
I can speak a little bit on I think what Jasper was asking. So, I mean, SQL's, I guess, not the greatest example because it's a fairly simple
Mhm.
um, language, so you're not getting a whole bunch of stuff installed regardless. But this is actually a good image to look at because you, instead of doing like where you just pull the entire SQL image, you can do command line in your Docker file and like be more specific about what you want and like how you want it done. There's some things you can look up online as far as like installing things into your apps where you can do it from the command line and kind of specify some things, add tags, flags, whatever. And
Yeah.
you can do that in the Docker file. You can.
Okay. I think I understand what you're getting. Yeah. Let's do. If you look up like Docker file syntax, let's go down here. Format. I was going to see if they have a. There's from
Probably what run, right? Like a run
run,
command.
right? Yep, run. So yeah, so this is the case that you can. Sorry if I didn't understand your question, Jasper. Basically, the Docker's file syntax has commands where you can do the same kinds of things that you would do like we were installing software. If you were copying files over from a local disk, if you wanted to run a process to create something, if you wanted to run a command in there, here's run command label, expose setting environments, copying things in, entry points in there, all sorts of things. So you've got all kinds of commands you can use in the Docker file to get exactly what you want in there. I thought you meant could you more of a splitting apart an image and such, but no, you can do, and this is the same idea. I use this, I overuse this analogy, but if you think about it from the standpoint of installing software on a computer, you go through different steps. You may take a package, an image, and then like an operating system and install it. Then you may run something to actually create some sort of output or customized, piece you want to have on that image. You might copy files from a flash drive or from a network location or something over. And ultimately, all of those steps are what you're doing to get that image set up and configured. It's what you're doing so that when that person turns on the computer, everything's ready, the software knows where to run, all those kinds of things. So the same kinds of things you can do there in terms of creating content, like through running a process. You could run like a make, you could run if you know the like an apt get, or you could run a copy something from a network location, all of those kinds of things to get pieces on there.
Cool. Yeah, that makes perfect sense. Yeah.
Okay, cool.
Yeah. Thank you, Brent. Thank you, Christoph.
Absolutely. So the web one we've got here, let's make sure, web image is along the same lines. We start out with Tomcat, and Tomcat, if you're not familiar with that one, is a web server. It's an older one, not used as much. Well, still around, but probably not used as much as some anymore. It's a web app server, so a web application. So the part of the application we're using here is just has some HTML pages and stuff, and it serves it up as a web application or a web app. Same kind of thing. We start out with a base image we pull down from Docker Hub, Tomcat, and here's the particular version that we want. Note that the version here specifies a little bit more information, JRE. That's Java runtime. It's a an environment when you're running Java, so you've got the right version there. The next piece here is an arg. That simply means that when I build this, I'm going to pass in something. I want it to pull in a file that I pass on the build command line. I could have just copied that file in from a local directory, but I'm choosing to pass it on the command line with the time I do the build. Then what it does is it does a copy command to say that thing that we just pulled in, put that file where Tomcat expects it. Put it into, so in, again, like if you're installing it onto a computer's disk, you'd put the files in the install location, kind of the same idea. Tomcat's going to look for it in a specific place on the directory structure of when the container is running. So put it in that place where it expects it. And then here's the command that will start up when we actually execute the container. So again, if I do like a Docker build here, let me just bring up, sorry, I'm getting my windows in the way of each other. So if I do this case, what I would do is similar to what I did for the database one, but I will actually, of course, change the Docker file that has reference to the set of instructions that has it. And then I'm going to pass in something that says build arg. So I have a little, this is an application I actually built. We won't go through all the build pieces here, but it's source code I compiled, created all that and built. I'm going to pass it in because I have this arg named war file here. I'm going to pass it in as the argument to that, which pulls it in, makes it available to the container. And then I'm just going to name my file here, my image war web B1 in this case. And so same kind of thing happens. We start out by pulling down the Tomcat image from there. We then pass in the war file. We then, if you're wondering about the intermediate containers, effectively each one of these instructions is creating its own container at that point, and then Docker kind of gets rid of them at the end and makes it into one single image. So then we copy it into location in there, and then we have a command to run. So that's how we create the images. And if I look at Docker images, and there's a lot of them out there, but if I simplify it to go to just grepping for the ones that we just created, you can see we have 2 images out there now. And then we could do the run to actually run them in Docker, or to actually run them and turn them into containers. Okay. So let's see what happens now if we look at this Docker compose file. So as I mentioned before, most applications these days are not going to be based on a single container or even maybe a few containers. You can have applications that require hundreds of containers. If we go into the, I don't know if you guys know what microservices are, the idea of having these individual little services that for each thing part of the running. Maybe there's a part for the database and the front end and the back end, a microservice to handle backups or a microservice to handle user input. You could have a container for each one of those that would be part of your application. So you may have lots of different containers. So we need a way to actually manage those together. When we're just talking about a couple of them, we can use this thing called Docker Compose. And I'll show you what this looks like. This is a Docker Compose is a tool for running a couple containers together. The larger tool is Kubernetes, which is what we started talking about, and we'll get back into that at some point. But Kubernetes is designed to manage all of these containers running together in what we call pods and managing those. But for a simple case like this, we can look at a Docker Compose file. YML is the YAML format. What did I spell wrong? Docker compose.yml. Oh, not type. I'm mixing my Windows and my Linux commands. So this is a compose file, which essentially is going to just run a couple of commands together. It basically run a couple containers together. Here's our ROR web container. This is just a label, and it says use the ROR web image, the image we created. I'll have to update that for V1 to make consistent with that. Then it says ports. What ports do I want to expose? So we can have the ports, the way that we communicate with the stuff inside the container. And there, we're going to be exposing it on these ports here, the incoming and outgoing port. Then we're going to link it to a service here running in another container. That here's our second container definition, RORDB container. This just says use that image that we just created, spin it up, and we're going to expose the database port, the port we normally talk to database on, out here on 3308. Then we have the environment. This is what I was saying, that these images, most of the time, they'll have ways to configure the images. They'll use environment variables. So when we're talking about using a MySQL image, in order for everybody to use it, you need to have a way to say, this is the user I want, this is the admin I want, this is my database that I want to access, whatever the case is. So this particular image is expecting this kind of information. And so what we're doing here is we're setting environment variables. We're effectively saying MySQL user equals admin, MySQL password is admin, registry root +1, those kinds of things. Now, this is a very simple case and not secure, obviously, putting usernames and passwords and stuff in this kind of thing. And there are better ways to do this when we start talking about things like Kubernetes and different things in there as well. But for the simple case here, we're just specifying enough in this Docker Compose file so that these containers can start running. Hey, Crystal.
Hey, I actually, we had that issue with Act where we have like a bunch of environmental variables. And so whenever we start the container, I just copy and paste this long, like run command that puts all the variables up.
Yeah.
Like, is there a better way?
There are certainly better ways. Yeah, if depending on how many containers you have, I mean, doing something like a Docker Compose file, I believe you can also may be able to specify a file on the Docker run command line that will have a list of environment variables. I'd have to go back and check on the syntax. But if you just have a couple of containers, the Compose is a good way to do that. Let me make sure that so my Docker images that I had, V1, see it has the V1 tag on it here. So I'm going to just edit my Docker Compose file. To make sure it understands that I want the V1, since that's what I created, images. So let's see what happens when I actually spin this up and running. So if I do Docker Compose, and Compose is not a Docker command. Docker Compose is a separate tool. We can do Docker Compose, and essentially, here's the list of commands you can do, all sorts of things: creating, stopping, removing containers, listing images, pausing services, so forth. The one that we want is the up command to create and start containers. So Docker Compose up, and let's see if it works. So it's actually running. What it's doing is it's taking the images that we had. Think of it like turning on the computer. You installed all the software on a disk. Now you turn on the computer. Computer starts loading everything up, running everything. Same kind of idea. We're creating containers. But we'll go back and take a look at what's going on here. If I can get back up far enough. Lots of stuff going on. Okay, so Docker Compose up. So it says, first thing I'm doing is I'm creating containers. So what did it do? Well, we had the two images, right? Now, if I do a Docker PS, that is the one that lets us look at containers. Remember that a container, again, kind of like turning the computer on, it adds on this extra read-write layer. in the container that says, here's where you can actually write data and store data. So if I do this, you'll see now that I have two images, and it's a little bit, let me see if I can stretch this out so it's not spreading across lines. Well, you can kind of get the idea. Here's the one image we just created, or sorry, the container we just created from the image that we had, from the raw web image. Docker Compose created the container from it. Now notice here that it tells us, okay, here's the command I'm executing internally, and then here's another one, here's the roar DB one. So we've just created a running instance of the image. If I do a, let's see if I do a Docker history of like such the image. Let's do this. Let's do a Docker exec. I want to show you what's inside one of these containers. So I'm using a Docker exec command to allow me to look inside or to get into a running container. Think of it as almost like logging into the machine, running in or logging into the container. So I'm going to do Docker exec -it, and I'm going to give it the database one. This is the ID of this. So I'll just give it the first couple of pieces, and we'll do bash. So what did I just do? What I did was I said, I want to be able to connect into the system that's running in this container. That's the IT basically says any kind of output, put it back to this screen, put it back to this terminal. The bash simply says run the bash shell inside of this. So now I'm inside of this container. Can you see this root at 534? 534 is my container. I'm the root user here. So I'm actually inside of the container and on its file system. If I look, here's the different pieces that got put into this container. They got put into the image. So just like if you were on a computer again and you installed software and then you got on it and you started looking around, here's the entry point script, the thing that it runs when it started. Here's the Docker entry point initdb. This is the same, we're inside the container. And you can see, here's the files that it copied from my local disk when we ran that Docker command. We ran the Docker build, and it did that copy. There's the stuff it copied in. You can see it also has all of the other things that were already present in the MySQL image. So now I've actually got inside of here, I've got MySQL installed. So I can do things like, let's see, admin. Remember, I passed in environment variables that said, what we wanted to work with. Let's just do MySQL admin. So now I'm in MySQL and I can show databases, those kinds of things, get stuff in there. So I can actually use the exec and get into the container, assuming it has a shell to run. So now I've got my containers running. I'll get out of MySQL, and now I'll get out of the container and go back to my system. Go back to the system where I'm running stuff. So I've got my containers running out there. And now with the Docker Compose, what it did, you can see what it did. It basically was going into, it said, I've created a couple of containers for you and I am starting them up. It's running that entry point script. We told it to start running that as the command to start working with when we started this. So it goes through and it's going through and just executing inside the container, executing the programs, creating the databases in there, doing all the stuff it needs to do to start it up. Likewise, on the website, it starts the web container at some point, starts running Apache Tomcat where it was installed, and keeps going through until everything's initialized. So it's going through basically and running those images. Think of it again like turning on that computer, everything starts running from the disk. And you can see here, here's the entry point script. It says I'm starting to run this, and here's where it's actually executing those commands that we copied in. The entry point script was something that the person who set up that MySQL image had put into the MySQL thing, so it could be tell it. But it basically just goes into that directory and starts executing some of this. Now it starts running these commands. So at this point, I've got everything running here from Docker Compose. And I can actually now do things like do a Docker inspect. Let's take a look at Docker inspect of our web container. So the Docker inspect here, what all this is information that Docker is tracking about this container, or information about what all is going on inside of it. There is a lot of stuff here. You can see different environment variables that are set. You can see where the files are actually stored out in Docker. So if you're wondering kind of how all this works behind the scenes, I won't go into too much detail. Let me go in here. But what Docker is doing for you is it is essentially going out here. Let's see, var live Docker. Okay, let's do this. Var live Docker. This is where Docker is installed. And if I look at this overlay 2 directory, this is the storage driver, or the way that Docker keeps track of how everything comes together. This is where the layers are stored. This is where the different things that went into those different steps in Docker file and created different layers, that's where they're stored. For example, the lower directory, let's find one that's not too cryptic. Let's look at this one, or maybe the merged one. Let's look at the merged one. And there's a whole set of things we could talk about at this level, but it's probably not something you really need to kind of get into. Let me see if I can just copy this in here, paste this in here. So the Docker inspect is telling us where Docker is actually storing this stuff. And you can see if I go in and look here into this, it says the merge dir. This is a directory just like any other with files and stuff in it. So the things that go into the Docker container from the image, they're all still stored out in your operating system. Docker just stores the layers. Basically, it's kind of like directories here. So the different layers that you see in a Docker history, or the layers you see we're creating, those are stored out here. That's what that var live Docker overlay 2. Overlay 2 is just the way that the stores it. Bunches of different things. These are all the different layers that are in the images you have on your system. They're combined in different ways to make up containers and to make up images, but these are all the different layers that go into it or stored there. So the inspect gives you lots of information about all of these things. Now, one of the other interesting parts about this, you can see the command here. It's running Catalina sh that we told it to run the Docker file. You can see the image it pulled in to spin up the container, working directories, network settings. So one of the interesting ones here is IP address 172.17.022. That says that this container is running and has this IP address that it can be contacted at. So what that means is I can actually go into my web browser and I can go to, let's do this, 172 172.17.022. 172.17.22. Let me hang on just one second. Let's do port 8080. Make sure I've got this right. So at port 8080, my container is running on this 172.17 IP address, and it's running Tomcat. That's what this container did, right? We set it up. Remember the first thing we did, or one of the first things we did, was we went into CAS class, roar Docker. Docker file, roar, web, image. We built our image running Tomcat, pulling it down and copying stuff in. And if we looked at the compose file, the file that actually tells us how to spin this up and how to turn these images into running containers, you can see here it said, hey, expose this on port 8080 here, expose it on port 8080. So our Tomcat container, now we can get to it, we can get to the application running it on port 8080. And then we've told it that in the compose file, we want to be able to access the database pieces, the database container, and that actually gets exposed here the way the program is set up, the source code is written itself. That's actually our application. This part, and it's kind of a silly thing, it's a registry of cartoon animals, but it's like a simple application just to have something to play with. So here's our database. It's coming from the database container that we have spun up. Here is our web app that's coming from that web app that we have in there that's set up, and it's hosting it on Tomcat. And so you can see we now have everything running in this container, and we have an application we can get to from both sides. So we took the Docker file, which started with the base images with the MySQL or Tomcat. We then customized it again, like we're installing stuff on a computer. We're copying files in, running commands to get things set up the way we want it, and that provisioned the image, the set of software out there. Then we did the compose, or you could do a Docker run as well, to start the container running, like turning on the computer and basically making everything run, which was what we saw with all the things it executed, started the programs running inside the containers. And then we were able to go in and look at the metadata in here. And by the way, there's a lot of stuff in here about all the stuff. The main thing we were after was the IP address where it's running at, but then we were able to go and actually look at the application running inside the container. That kind of give you an idea of how things tie together. And, you know, it's interesting. I mean, you can see it as well if I go and do something like Docker stop. Let's see, what's the, so if I do a Docker stop on our container that's running the database piece, so that means 534 is stopped. And if I hit this again, the database has gone away. Okay, so so you can see the idea, this is actually running in those containers. But this gives you a very powerful model because of things like when you're testing an application. If you can put your application in a container, you can spin it up or spin it down. I mean, I can just, you know, I can very quickly, if I am in here, if I kill this off, of course, this will be gone again. And eventually the cache will go away, but I can always do a Docker compose up and start up another instance of it. So you can imagine if you wanted to do things like if you're creating software testing, if you want to test your application, if you can put your application in a container, you could even put the testing tools in there. You could even put the applications you want to run tests and just have them as the thing that spins up or starts up when you run that and run your testing for you, and very cheaply and easily go back. So the cool thing about this is, well, there's lots of cool things about it, but let's see where this one is at. Docker, I'm going to say, give me information about which images are running, make sure my containers are running. And I'm going to look in this web container again, Docker inspect, and I'm just going to say grep for IP address, just to kind of, so I don't have to scroll through all the data. And it says it's running on 172.17.022 again. So if I refresh, everything's back because I just spun it up again. But you can start to see in terms of creating software and creating environments and creating things you can work with, all we have to start with is these Docker files. We just have the code, we just have text files. So this is what we talk about: infrastructure as code or pipeline as code. Anytime you hear those kind of things like this as code, there's talking about having these text files. And then you can run these processes that can take these files of instructions and end up with the containers running out there, end up with things that you can actually work with. So this is a very powerful kind of idea, because now, instead of like in the old days where we'd have to go and get a computer and put a disk in it and install CDs or software on it and do all the things with a physical computer, we just have a Docker file, and we start that and we spin it up, and we have the equivalent basically of a container, of a computer, because we have these containers that are running out there with the applications running in them. But now I can just I could take these files, and if I could put them in Git, for example, in source control, and I could do code reviews. If I change something, I can share them with other people. I can start them up, and if I need to change something, I can just tweak something, change, edit. If I need to get a different version of MySQL, I could just edit this Docker file raw web image and tell it, instead of 5.5.45, pull version 8 or something. And then I get a whole new image down from that. So it's a very powerful concept that I don't have to mess with physically installing software anymore or doing things on a machine. And the other part of it is, if something goes wrong, if my database gets corrupted or goes away, I can just stop the container. I can just stop the container. I can delete it with the Docker RM. I mean, let's kind of clean up everything here. So I've got my my containers that are running. So I'm going to stop the containers for running. Stop 8F9, which is the web one. And I'll do a Docker stop 534. I'm looking at the first few characters of the checksum or the digest here. All right, so I got rid of my containers. And if I want to look at the images, I get that stop the containers. That didn't actually get rid of them. They're still there. If I do a Docker ps-a, I know we haven't talked about all of these instructions, but you can see basically the container is still out there. It's just in a stop state or exited. If I actually want to get rid of it, then I need to do a Docker RM 8F9 Docker RM 534. And then I can also get rid of my images. It gets rid of all the layers, all the things that were stored out there that nobody else is using. So they don't take up room on my disk. And I can also get rid of the database one. Oh, unable to remove, something else is using it. So I can force it. I go ahead. There we go. And that's just getting rid of the areas out there on that Docker var or var Docker, live Docker. So that's just a quick hands-on thing. I hope that's useful and kind of helping you guys understand a little bit more about what's going on, how things map there. I'd love to stick around for questions, but unfortunately I've got a 1 o'clock I've got to run to. But feel free to reach out with other questions or something. Crystal's got my information as well if you guys want to ping me with things you have, or think of them for next time. And I think next time, if you guys are good with it, we'll carry this on, and I'll show you kind of how these things fit into Kubernetes. Sound like a reasonable plan? Cool. Is this useful?
Yes, thank you.
All right, great. Thanks, guys. I will see you all next week.
Thank you.
All right, have a good week.